Hey guys, so welcome to the Dynamic Analysis Lab. Here we are gonna be running different examples, real example with real malware finally, so that you can guys see how we can use those different tools that we learn in our slides and in Arsenal 101, so that you can definitely play with real malware and start, understanding how to analyze it. This is whole dynamic analysis. There is no reversing, there is no code involved. It's all trying to find all the details about the malware without even going into any details. Okay, so but the first thing I want to show you is when you are dealing with DLLs, right? As I told you, when you want to run a DLL, since the DLL is a module that doesn't run by itself, you need to use some steps in order to run it in your system. So let's go to our virtual machine, and here we are going to open LordPE. And with LordPE, we're going to open our DLL, okay? Which we just created for you during this exercise. It is here in exercises, DLL. So this is a good practice to always open the binary or the executable, in this case the library, and kind of understand the properties of the file before running it. So in this case, this is not malicious, but I'm going to show you the different components. We know that this is the PE header. If we go here to directories, as you remember, it will have an export table because that is exposing the functions available by this DLL. If we click here in this dotted button, we can see that we have mainly two functions being exposed, function 1 and function 2. Okay, so for a malware, we will have here any other functions, and what we want to do here is we want to run the DLL and call in those different functions in order for the malware to execute, and then with our monitoring tools, we can see what it is doing. Okay, so in order to run it, we're going to use a program already in Windows operating system, which is called run DLL32. Okay, with that one, we need to pass the path. Since we have here in the same directory the DLL, we just need to put the name. Otherwise, you need to put the full path. Then we put comma, and then we are going to call one of the exports. As you remember, one was function 1, and the other one was function 2. So let's put here the name function 1, and let's see if it runs properly. We click enter, and it says the process cannot access the file because it's being used by another process. That's gonna be our LordPE. And here is important to mention that we need to close LordPE because otherwise it cannot be accessed. But it is important to say to see here that it is function 1 and function 2, the exports. Just keep that in mind. So we just click OK, and we close it. And now we should be running fine. You can see that it is a pop-up saying inside function 1, which is telling us that we definitely execute the first function. The same for the second function. If we click here in function 2, we just run it, and we are executing those specific exports inside the DLL. In this case, it's just a message box, but in a real scenario, you will run the code for that specific function. Actually, the sandbox that run malware automatically, they will grab all the different exports from the DLLs and will run it. As mentioned during the slides, if those specific exports expect a specific parameter and we don't supply it, then it won't run properly. That's the limitation. In that specific case, we need to reverse the DLL in order to understand the parameters and pass it here during run DLL run. If there is a parameter, we can do a space and put here like parameter. Okay. In this case, it's running properly because there is no parameter expected, so it is just discarding that one. But also, something important is that if you put an export that doesn't exist, like function, it will right away throw an error saying, hey, this is a missing entry. There is no function export in that specific DLL. Okay, guys, so that's all about DLLs. So make sure that you run it. And something that you need to do is you need to run process monitor, process explorer before running this step, so that if there is any malicious action, you can track it. Okay. Um, Now let's go to analysis on the sandbox. So basically we have here a sample that it is SUS sample. SUS, for you guys to know, is most known as an info stealer. So basically is able, it's a well-known malware, and it is able to steal credentials from the systems. It is also able to steal banking information, so that it can use your information in order to steal PII, which is personal identifiable information from you, like credit card, phone number, social security. So basically, it's a info stealer able to find sensitive information in your system and upload it into the CNC, which is the attacker's server. So here is the MD5, so that if you want to take a look, obviously you will have the chance to run it in our labs. So this we run it, this specific malware, in this host, which is owned by Payload Security, and this one we run it in two different profiles. Okay, so basically, if we put here the MD5, okay, and actually let me do something quickly. We can go to Reverse.it, which is the main site. You can upload a file from your system, or you can definitely go here and do search. And in this case, we're gonna be able to see our MD5, okay? Here we run it with two different profiles. One was XP, and the second one was Windows 7 32-bit. You can see right away that the malware in this specific case is connecting to USA, and in the second one is connecting to Switzerland. Okay, but we also have another run, which is through Cuckoo Sandbox. Here we also have our MD5, which is the same, and a quick explanation of what is going on. So let's look at these examples first, and let's see if we can grab information about this malware. So this quick overview is going to tell us the name of the file. In this case, is order PO, the size, when it was run in the sandbox, when it was done running, the duration of the run, or some information about this specific malware. Then we're gonna see here that some specific activities, like it performs some HTTP request, it says steals private information from local internet browsers, which kind of give us an idea what it is doing. The process ID, here it is saying that it's like a banking Trojan. When you see a banking Trojan, might be related to info stealer family and could be SUS, like in this case. So it's kind of confirming what I told you. Here is grabbing actually, the HTTP request, going to this specific website, to this specific URI gate PHP, the user agent, which is kind of singular because it's using a Windows 98 string, which is not common nowadays. But anyways, it's gonna give you ideas. Here it says it's harvesting credentials from FTP clients, so it's kind of probably stealing FTP credentials. And then it also offers you a screenshot. In this case, there is nothing, but it would be good if there is an error message or something that can tell you that it didn't run properly. It also talks about the Windows startup, if it was something found inside the registry or the folder, startup folder. Sorry, in this case, in the startup folder, which is a normal place to put malware so that it can run all the time. Here we can see the details a little bit. We can see the host. Write it down because probably this will be seen multiple times. So it is 198.15.113.99. And here is the domain pointing to that specific IP, so that you can know more about this specific domain. We can always query internet about this specific IP and the location, but as you saw in the other sandbox, it is telling us that it is from Switzerland. But what we can do here is we can just quickly gather this IP And I'm gonna explain you what we do normally. So we open our browser, and we go and find a website that do IP lookup, IP location based on IP. So we can come here, put our IP query, and it's gonna say in some seconds it's running. It's gonna say, okay, you know what? This specific IP is belonging to United States in Arizona. So that's kind of interesting that this specific IP it is in USA. So probably might be a compromised website, or it is just a malicious server set up by the attackers in USA so that it doesn't throw any alerts. We can also use here domain tools, which is another website that offers basic WHOIS information, but it is pretty useful. So we put here the IP again. It is asking us to enter numbers so that it is validating we are not a robot. And it is also again telling us, this is an IP located in USA, and it is being hosted by secure servers. That's the hosting facility, which is very important for us, because if we detect that this is something malicious that is serving malware, we can reach out to the hosting provider, and that can help us to shut down that specific website. And since it is in USA, it is easier for us in this case because we are in USA to interact with this hosting provider. But let's imagine that the hosting provider is in China. It's going to be hard for us to reach out to them. Okay, so these are just basics about what we can do with that information. And then coming back to our Cuckoo Sandbox, we can see at the end in the summary 3 tabs. Let's go with the files one. In the files tab, it's going to tell us the host-based indicators. You remember about indicators of compromised term, IOCs? Well, this is exactly what we are going to see here. In the file, it is host-based indicators. In this case, it's going to tell us what is going on with this specific malware. We can see that it is dropping the file in temp directory so that we can go there and grab it. We can see that it is, consulting these specific folders, and it's going to be a lot of information. We start seeing that it is kind of consulting ftp.ini. This is not kind of clear what it is doing. If it is reading, writing, creating, it's not clear, but we're going to see the details in a second. But here is just telling us what is going on. It's probably opening this IP switch, which is a FTP client. We can see then Qt FTP, which is another FTP client. So we kind of start understanding that it is kind of trying to find different software related to FTP, right? If we keep going down, we are going to see now FileZilla. FileZilla is another FTP client, a smart FTP. So it's kind of trying to find different FTP clients in our machine, right? As we can see here. If we can going down, okay? So that's kind of a very interesting finding that we can help us to understand. If we go to the registry keys, it's going to tell us what it is doing in the registry. We can see here AutoIt. Trying to open AutoIt. That might be related that it is using AutoIt. AutoIt is just a legitimate software to scriptable, or in other words, to automate tasks in Windows, okay? But it is also well known to be used maliciously by attackers, normally to obfuscate the malware, like in this case can be the case. In the registry, you can also see that it is also going to current version, which is find versions of software. If we go down, we can start seeing some queries in those uninstalled registries. If we don't know what is this, we can just quickly go and search in internet about what is this specific current version uninstall. But it is telling here, I can tell you that it is just querying for software that has been uninstalled in the system. And then we can see here that it is going to other different software. It is kind of scanning the software running. Total Commander is another software which also has, Windows Commander and Total Commander, which also have FTP clients. Now we can see again the Qt FTP. It is kind of trying to search for this specific software, but with different versions, professional, home, different versions of that. So it's kind of searching the registry, also trying to find information about that specific software, bulletproof FTP client. So basically it is doing the same, but now here it is trying to find the versions in the registry that is going to lead to a specific location in the file system for the malware to harvest credentials. Okay, you can keep digging. It's a good exercise for you guys. Then we go to mutex. Mutex, I explained multiple times during this certification that in the legitimate side, it is just a way to synchronize threads. Okay, when you're running a program, it has multiple threads. You can use mutex to say, okay, this thread, whoever wants to access a specific resource, it will create a mutex so that the other threads will wait until that mutex is released. When it is released, that tells the other threads that they can start using that specific resource. It's kind of synchronizing the access of a single resource so that not everyone at the same time starts using it. But maliciously, the attackers normally use mutex so that they can create a specific name in the thread within the process running, and they can say, hey, here is the thread the mutex created, and if by any chance that specific malware runs again in the system, they will check if the mutex is already created, and if that's the case, it won't run again. It's a way to detect if the malware is running multiple times so that they don't run the malware multiple times and don't reinfect the system. That's normally useful because they don't want to throw some alerts and be noisy in the infected machine. In this case, we have multiple alerts created by this specific SUS malware. What we can do here, guys, we can search in internet for those specific mutex names, because this is in our detection strategy. We can use mutex to identify families. We can say with this mutex we can identify this kind of SUS families, or even we can add it as a detection. So let's copy paste this one, which looks like it is unique. I'm gonna open Chrome, and in Google I'm just gonna check for this mutex just blindly. Okay. So we can see that right away we get some examples about analysis, virus analysis. We can even see here in Trend Micro, they are talking about this MS history. And if we click on that, they are talking about this Trojan. If we search in this page for the mutex, we can say that it says it adds the following mutex to ensure that only one of its copies runs at any time. That's what I just explained you guys, okay? But here we can see that it is the same mutex. So probably our malware that we are dealing with is related to this family, or is coming from the same threat actors, okay? So that's very useful. Now let's check another options here in the Cuckoo Sandbox in the left side menu. So we just went to quick overview. We can go to static analysis. Static analysis, we confirm here that it is using AutoIt script, the PE imp hash. This is very important, guys. This is very important for hunting strategies. So basically, it's gonna do a hash against the import table, which are all the DLLs being used by the malware. It's going to run a hash, which is a tool available, and it's going to give you this hash, which basically is telling us this specific malware has this imp hash, which is the import tables being used, and that way we can run and scan with Jara, which is another tool that we're going to see in our Defender Techniques course, that we're going to find all the samples, all the malware which has the same import table. It's very useful for hunting strategies and for clustering, so that we can, group specific malware families. Here is the sections of the file, this kind of an static analysis, some of the resources, the imports, guys. The imports is very important because we can see what are the different libraries being used. We can see right away that it is using WinSock, which is related to internet connection. So right away we can see that this malware is able to connect to internet. It has that capability. That's telling us really good clues about the malware without even running it. Okay, so we have other DLLs, when iNet, which is also related to internet, to HTTP connections, as you can see here, open request, send request to send HTTP requests to web servers, and you can see others, right? all of them. This is really interesting, write process memory, because that is related to process infection. You can check the malware tricks course so that you can understand how the process injection works. So it is telling us all different information. Feel free to go through all of those different import DLLs. Behavior analysis, that's really cool, but this is going because this is going to tell us what is going on inside the system. We can see the different colors that is going to tell us different activities. Like network is going to be in green color, in this case is blue, which means it's process related activity. We have registry in orange, like synchronization in pink, and file system in orange, and services in purple. So if we go down, we can start seeing all the different activities based on those different events. We can go even for all the different sections, guys. We have here the pages. This is the page, this is right now the page number 1, and you can see here it has, this is in white, which means there is nothing like malicious. Then we have this in pink, which is registry related. It is trying to open this specific registry. You can go in details. In the orange, it is the system related file system. You can see that it is creating this order file in the system, and you can go to all the different options here to know what it is doing, to go a little bit in detail. So we're going just trying to browsing all of this. We can see that it is reading some information. You can go deep, obviously, if you want. Here is also opening some other registries. This is a different color. And as I described before, it is just going to describe every single step going on in the system. Okay, more registry information. We are done with this page. We can go to second page. And here in the second page, we have something like services. This is very interesting because it's using this API, device I/O control, which is basically an API to interact with drivers. So might be the case that this guy is installing a driver in your system, which is also known as rootkit, to hide its presence in the infected machine. If you want to know exactly what it is doing, you need to do a reversing in this case. We cannot do anything with dynamic analysis. That's one of the limitations, but it is giving you clues what you need to look for, like the I/O control code. This I/O control code is a specific instruction to query the kernel. You can look it up in internet what it is doing. Okay, so that's all related to device I/O control, which is very interesting. Then we have other information, as you can see, and you can go down and see exactly what is going on. I'm just trying to point out some of the main activities that you are gonna be able to also find it. This is a Cuckoo Sandbox, is in internet. You can quickly search for that MD5 and you can replicate the same exercise. Again, we have multiple, you can see multiple registries. It is trying to open multiple options. I want to try to find another something different for you guys to know. Let me check if I find something different. It is again opening file system. Let's go quickly to the 4 page. It is again the same. Let me try to see if there is something more here. It is other colors. Create mutant. This is the mutex call, so that you know that it is creating this specific mutex name in the system. It is what we just saw, right? Set Windows hook is very interesting because this is going to create, it's going to intercept the messages in the system so that it knows what you are doing. With the number 2 is, if I remember well, is the mouse events, and number 7 is the keyboard events, or other, it's different. Either one is keyboard and mouse events, and that means it's going to intercept everything being typed in the system. Which, if you want to know about keyloggers, also check our malware tricks course so that you can see the details. And yeah, it is, going open another mutant here in pink color, and it's basically all about this. If we go to number 6 page, we can see create process. It is running this specific malware a second time. This write process memory is very interesting, guys, because it is telling that it's basically injecting itself it is running. I mean, this is because with a little bit of experience, right? You will understand. So it is basically running again itself. When it runs in memory, it will override content of itself via write process memory, which is used to write code in memory process. Again, malware tricks course is going to explain you in detail these steps. Okay, guys, so that's basically what I wanted to show you. So you have all the information on Cuckoo Sandbox. If there is any network analysis, in this case it's just the IP, there is no information. But if we go to HTTP, this is awesome, guys. You can see that actually it is going to this specific URL, and we have here all the information. We have the post request, all the HTTP headers, so that we can know exactly what it, well, we can see the traffic going out, and we can add detection in snort-based detection in the network to stop this traffic, to stop this threat going on. We can see in our Defender Techniques course that we can how we can add snort detection. The post information actually is also sent some data. We don't see it here, but we can see it with a different approach, like we're gonna see in our lab in a second. Okay, so basically we have all those calls, which is huge, which is awesome. And if it is any dropped file, which is very interesting, we're gonna have it here, which is very important because sometimes the malware runs, do a lot of different actions, obfuscation steps, and at the end is gonna drop the file into the system, which is actually the malicious one. We can just jump right into that one, skip all these different steps prepared by the malware authors to divert analysis, and then we can just quickly go to the meat in order to find the malicious actions. Okay, so that's pretty much it. With this one. We can just quickly go to the other one, which is payload security. It has two different options. If you see, these are going to different countries. So if you go first with the XP one, okay, we're gonna click on it. It's gonna also give us its own way to analyze this specific malware. It is taking some time. I don't know why, but anyways. So here we have this one. It is running in a Win32-bit machine. And if you check right away the IP, okay, guys, you can look it up, this IP, and it is an IP related to a hosting provider. It is not a connection based on malicious actions. Because you can look it up and you will see that it's Akamai, which is a well-known service, internet service. So it's not accurate. And actually it's not also giving us the same IP that we discover in Cuckoo Sandbox. So something was wrong with that specific profile. But if we check the second one, which runs on Windows 7 32, we're gonna see that the IP that we found in Cuckoo Sandbox, which we can see right away here, is this IP, right? 198.15.113.99. We can see here that when it opens, we have here 198.19.85.16.153. Okay, that if we compare is different, but guys, check this domain, panel3doxfrontal.com, which is exactly the same one that we saw here in the host, panel3doxfrontal.com. Basically that means it is the same host but with different IPs, which is totally normal. But this is telling us that the malware is probably using different IPs going to the same domain. Okay, but this confirms that this is the right profile. It is same as the one that we saw in Cuckoo Sandbox. And in the right side, we have all the different information about this specific malware. So again, we can go all the signatures. It's gonna tell us about, the malicious actions. I don't wanna go again to the same, guys. Feel free to play with this information. It's gonna tell you what it is doing. Right here is saying, hey, it is trying to interact with the device drivers. And if you remember, we talked about that because of the device I/O control that we found. So here is also reflecting the same finding. We can go to the suspicious indicators, some of the anti-reversing. As again, feel free to go to those different steps. I don't want to worry you guys. It's exactly the same that we saw before. Here is the icon. This is interesting. It is presented as an Excel file, which is kind of normal. Is the way the Trojans work. If you want to know also about Trojans, what is that? It is explained in our courses. It is basically trying to present it as a valid or legitimate file, but that's the reason of the icon, like an Excel, so that you can just think it is a valid Office file, but actually it's an executable, okay? And here we have all the imports, as I discussed before. It is quickly telling us what it is doing. WiniNet is related to connections to internet. And actually you can see here the FTP API. It's not only HTTP, but it is also FTP. That's very interesting, okay? Also, we have screenshots while running and the network traffic, okay? Contacted countries, which is really cool. In this case, it is saying this specific host is in Switzerland. That's really useful for us to know where it's located. It is not in USA like the IP that we saw previously, but it's going to tell us where it is being hosted. Well, it can tell us that. So we have all other information here. We can even have the various dollar report. So this is the dynamic analysis, guys, going through to the sandbox available in internet, so that you can have all the information. As I said before, it's not recommended to run it in those sandboxes. It's better for you to actually implement those kind of sandboxes in your lab, in your network, segregated. So we highly encourage you to use Cuckoo Sandbox, because that's open source, and do it in your lab, okay?